Okay, good afternoon, everybody. 30 minutes is not much time. I've done presentations where it took me 4 minutes to get to my first verb, so let's get right to it. My thesis here today is that relational DBMSs have been so dominant that relational modeling has also dominated, and it has subsumed some other forms of modeling that really should not have been subsumed, and most noteworthy among those is conceptual modeling. And conceptual modeling really needs to be a freestanding endeavor that is not sullied by relational modeling. And unfortunately, as DBMSs wane, these intermingled relational forms of modeling, relational modeling and conceptual modeling, also wane, and relational modeling sort of takes conceptual modeling down with it, and that's inappropriate, and we really need to rescue conceptual modeling, and relational modelers are reasonably well equipped to do that. So my perspective is hard won. I've been in the industry for, I'm in my fourth decade now. I've spent a certain amount of time in product development for large vendors you've heard of, Digital, Lotus, Microsoft, Bachman Information Systems. I've spent a lot of time in the enterprises, in organizations that were the consumers of the products that were made by those vendors, and I've spent some time as an industry analyst for Burton Group and Gartner, and I've written some books, and I still consult for enterprises and for vendors. I specialize in all things data and in particularly modeling and requirements analysis. So I'm going to talk today about history, current events, and the future. Doesn't cover that much. Starting with the history, let's talk about this big picture framework of data modeling. The framework has got 3 rows in it. It acknowledges the differences between conceptual modeling, logical modeling, and physical modeling. Conceptual modeling should be completely untouched by technology concerns, sometimes called technology neutral, technology agnostic. I call it technology apathetic. When you're doing conceptual modeling with users, you shouldn't even care what the implementation environment is. If you find yourself caring, you're not doing conceptual modeling right. Physical modeling, of course, is when you're actually in the business of implementing the solutions. And logical modeling is this middle ground where you have begun to make some decisions about the implementation. In particular, you have chosen a particular implementation model. Maybe it's the relational model, or it's object-oriented, or it's XML, or it's key-value store. So that's a very nice framework, and in particular, there's a lot of interesting and good ideas in of software engineering that are evident in that framework. One of them is certainly information hiding. For example, that framework conceals any kind of implementation details from the users who are participating in conceptual modeling. The type instance distinction is evident there. When you are building conceptual models, we're talking about types of data, and we're doing type-level thinking, not instance-level thinking. We're describing the categories. It's also evident on this framework is application and data independence. It's a little more subtle how that is evident from that framework. It's because the framework has got only one column in it, which is the data perspective. You just as easily have drawn another framework which has got 2 columns, one for the data perspective, one for the process perspective. The fact that it's excluded doesn't mean that it doesn't exist. It's just for this particular framework, we are focusing on data, not mentioning process that much. Such a framework is the first step towards much more elaborate things that have got many rows and many columns, enterprise architecture frameworks like the Zachman framework. The distinction between user requirements and system requirements is manifestly obvious in that framework. And what's important about that is that you should not expect that your articulation, your model of the user requirements is going to necessarily look like your eventual model of the system requirements, only with less detail. It may very well be that your model of the user requirements doesn't look much like your eventual model of the physical storage layer of your application at all. It may be that your storage layer uses a very generalized approach, but the conceptual model probably should not use an especially generalized approach. If it's too general, if it's too abstract, then the users won't be able to tell you when you're right and when you're wrong. And then, of course, model-driven development certainly becomes possible in a framework like that. There's forward and reverse engineering across the rows of that framework. It's wonderful that that framework shows all those nice ideas, but what actually is done in practice is something much more impoverished. What typically happens is that folks do relational modeling and they do physical modeling. There's a lot of mistakes that are manifest in here. And I can talk about sort of why they came up. I'm going to skip over them. They're in the slides. You can read them. But as I say, 30 minutes is not much time. But the situation that we end up with is that you end up with only 2 levels, relational modeling and physical modeling, and relational modeling, not logical modeling, but the specific form of logical modeling called relational modeling, ends up being used for user requirements. So that's the history. The current events are that along comes NoSQL. Now, NoSQL has a couple of interpretations. One of them is the sort of Nancy Reagan-esque, just say no to SQL. And that's very strident. And if you really are just discarding everything relational, and you're using this impoverished framework rather than the grander framework that I was showing before that has the 3 rows that acknowledge the existence of conceptual modeling, and if you're throwing away relational, you end up with a very, very impoverished model, which just has a very, very impoverished framework, which just has one form of modeling, which is physical database design. And for folks who have got experience, have built their career out of being experts in relational modeling, even that physical level of design isn't relational modeling anymore, because you're in a NoSQL environment, you have just said no to SQL, and so the physical design is not something that relational folks are accustomed to. It's going to be based on big table implementations or some other flavor of NoSQL. So it puts the person who has built his or her career on being an expert in all things relational at quite a disadvantage. Now, there is a slightly kinder, gentler interpretation of NoSQL where the NO stands for not only. So in not only SQL, all right, if you're in an environment where they acknowledge that there may be some use for SQL-style relational approaches to solving problems, then there may be some work for you. But you are at risk of being marginalized, maybe by having to be part-time. So that's it. That's all I want to say about the history and the current events. And now I want to talk about your future as a data modeler. Basically, you want to remain relevant. The sort of small-minded way of thinking of this is you want to keep a job. You want to save your career. A more noble way of thinking of it is you want to figure out how, with your skills as a relational modeler, you can continue to serve your clients, your customers, your enterprise, your company. And one thing you can do is just wait for relational projects, and that's sort of the marginalizing approach. One thing you can do is to become a NoSQL database designer, learn about key value stores. That certainly is a good thing to do, but that kind of thinking sort of reminds me of the hoary old classic that you hear in business schools, the anecdotes about how if the railroad industry had figured out that they were in the transportation business, then they wouldn't have had their butts kicked by the airline industry. And you need to have the same kind of thinking, that you're not in the relational database business and you're not swapping that business for now being in the key value store database business. You want to be a data person and solve data problems. And more specifically, you want to help your clients to choose to make informed choices and judicious choices about what kinds of data platforms they're going to use to solve certain problems. And that starts with understanding the customer's problem, and that starts with conceptual modeling. So I want to resuscitate the grander framework that I presented before, where there's 3 forms of data modeling, and they are conceptual and logical and physical. Now, most of what I'm going to say hereafter is about conceptual modeling. This is sort of a mini agenda for the remainder of this presentation, and it's a little dishonest, because mostly what I'm going to talk about is that first bullet. I'll talk a little bit about the second bullet, and I will fly through the last 3 on a single slide. Mostly what we're talking about here is how to do conceptual modeling with the skills that you have as a relational expert. So there are certain behaviors and there are certain constructs, building blocks of relational models that you know about, and you are going to keep some of these behaviors and some of these constructs. You're going to discard some. You're going to stress some in ways that you haven't stressed them before, and you're going to change some. The ones that you're going to keep, well, hang on a second. So here's an example of a conceptual data model. You can certainly forgive people for confusing it with a relational model, because they certainly look very similar. But if you look closely, you'll see some things that are not valid on a relational model. You'll see some differences. One is that there's a many-to-many relationship on the bottom between tag and note. That's a no-no in relational modeling. The other thing you might notice is that there's no foreign keys. Foreign keys are a relational specific construct that you don't need when you're doing conceptual modeling. There are a lot of other differences, and I'm going to go into those a little bit now. I said, keep some, discard some, stress some, and change some. What you're keeping are entities, attributes, relationships, identifiers, and maximum cardinality. That's the presence or absence of a chicken foot or a crow's foot on a relationship. And that's it. That's all you keep for doing conceptual modeling. You keep entities, of course, because, well, you have to have a minimum level of expressiveness on your conceptual model. You don't jump over a ditch incrementally. If you don't have entities, you're not making it all the way across the ditch. You're keeping entities, not tables. So one of the things that means is that you're interested in entity names, the names of categories that your constituents would use in their business conversations, not table names that you get from your IT naming conventions, from the naming restrictions that your particular product might impose. It means that you're not necessarily going to be modeling all the tables that you might eventually use. You are going to model whatever categories the users recognize as existing. You're going to keep attributes. This is one of the things that a lot of folks say don't belong on conceptual models. In particular, vendors of data modeling tools will be dismissive of conceptual models, and they'll say, oh, it's just a conceptual model. You just have a few entities and a few relationships, and it's like a back of the envelope kind of calculation, just a little sketch. That's poppycock. Attributes should make the team cuts on conceptual models because attributes have names that would pass the user's lips as they're talking about their particular business. Credit limit is an attribute. It's going to end up being an attribute on any data model that I've ever seen. The fact that it's an attribute doesn't mean that users won't talk about it. Users will talk about credit limit all the time. There are certain things that are going to end up being columns, are going to be attributes that are clearly part of the IT business. You know, a column or an attribute named date of last backup. That's something that's an IT internal thing. That wouldn't make the team cuts. But just because something is an attribute doesn't mean that it doesn't make the team cuts. In particular, one of the things you have to support is in-progress models. And many attributes, many things that are eventually entities, start their lives as attributes. If you want to catch those entities on a conceptual model, you have to start by talking about those things while you still think they are merely attributes. You keep relationships. Here, you're not talking about foreign key relationships, you're just talking about those lines. One of the things that means, and one of the differences between the relationships that you talk about on a conceptual model and what you talk about in relational modeling is that you allow many-to-many relationships. The other thing is that you allow collection entities. An example of a collection entity would be if your clients are a hockey team and you've got an entity for player or skater and you've got an entity called squad and there's a one-to-many relationship between them because each skater can be on many squads and each squad can have many skaters. And the identifier of skater is his jersey number and the identifier of squad is just the set of skaters who are on it. Now that may seem like a very exotic and alien kind of construct to you, and that's because the relational model has poisoned your mind. There's nothing alien or exotic about that to users. It's a perfectly legitimate conceptual structure of categories. Again, we're talking about relationships, not foreign keys. Certainly you'll keep identifiers as part of a conceptual model. Identifiers are not, as programmers, a lot of programmers might think, are not motivated by the software world. Identifiers exist. I'm here talking to you now, and I'm speaking using natural language. Somewhere there's a bunch of transformations where we get from natural language to storing things on computers. We need identifiers eventually when we get to storing things on computers. The change that requires identifiers is the change from spoken language to written language, not the change from written on paper language to stored in computer language or to computer automation. I can say, this tree has Dutch elm disease and that tree doesn't. And I'm using spoken language, and I'm taking advantage of a lot of the tricks that spoken languages allows. I'm using indexical words, pronouns like this and that. I'm pointing. If I want to write that down on a clipboard, I have to somehow say, well, okay, how do I identify that tree? And I've used latitude and longitude or something. And the one at that latitude and that longitude has Dutch elm disease, and the one at that latitude and that longitude doesn't. It has nothing to do with computerization. It has to do with the switch from spoken language to written language. And so identifiers, semantically meaningful identifiers, not globally unique IDs, semantically meaningful identifiers are part of conceptual models. The other reason why identifiers are important is to support the process of modeling. And identifiers are very useful for me as the modeler in front of clients to ferret out, detect, and remedy the homonym problem. And the homonym problem happens when a user community uses the same word as the name for two different categories. And if the user phenomenon is alien to me, which it might be because I'm the modeler, I'm the stranger here, I might have trouble even realizing it. And they, of course, don't have any problem with it because they have so much context that I don't have. So demanding that users employ semantically rich identifiers, demanding a semantically rich identifier for every draft entity that I might encounter during conceptual modeling helps to ferret out this very vexing problem called the homonym problem. So I said, keep some, discard some, stress some, and change some. What you discard are foreign keys. They're a relational construct. They have nothing to do with being on a conceptual model. They're also redundant with the line that you've already got that exists between the two boxes. You also discard minimum cardinality. Minimum cardinality, this is sort of an interesting one because it certainly feels like a data requirement. Data definition languages let us articulate null and not null constraints, minimum cardinality constraints. But when you think about a particular piece of minimum cardinality constraint and which person in an organization holds the fate of a minimum cardinality constraint in his or her hands, it's the person who designs process. And if I put a minimum cardinality constraint on a data model and on a conceptual model, and then I hand that model to some downstream consumers, including people who design process for a living, I have circumscribed inappropriately the universe of possible solutions that process modeler can come up with because I have imposed a minimum cardinality constraint on this thing. So minimum cardinality constraints, like all constraints, are also grossly over-reported by users. So you're wasting a lot of time struggling with users to get them right, and it turns out they're almost always wrong. The rule of thumb for what you keep and what you discard is that you are keeping anything that helps you and the users together discover the topology of the model and articulate the names of the pieces of that model. And you're discarding anything else. Now, I should say, discard here doesn't mean forget about permanently. It means omit from the conceptual data model. There's some time downstream where you may want to consider the existence of these constraints and the values of these minimum cardinality constraints. It may be when you're doing process modeling. It may be when you have moved down to logical modeling. They just don't really belong on a conceptual model. So on the left here is the conceptual data model we've seen already. On the right is another one. These were made a few years ago by my colleague Peter O'Kelly, so they may be a little bit out of date, but the one on the left is about Evernote, and the one on the right is about OneNote. And you can see how richly expressive this is just with those 5 things: entities, attributes, relationships, identifiers, and maximum cardinality, that users can very quickly compare Evernote to OneNote and say, oh, well, OneNote allows much more fine-grained tagging. You can tag an individual paragraph in OneNote, whereas you can just tag a note in Evernote. So it's very, very effective, just with that spare notation. So keep some, discard some, stress some, and change some. What you're going to stress that you might not have stressed before are 2 things. One is consistency requirements. Folks who have done a lot of relational modeling and called it conceptual modeling or called it requirements analysis have not really been in the habit of asking the users about their consistency requirements. Now, if you've done a lot of distributed solutions, maybe you have. But for standalone relational systems, nobody really ever bothered to ask about consistency requirements because there was no need to. Because whatever consistency requirements the users might have articulated, with a standalone relational system, you were going to satisfy that consistency requirement and then some, because you're going to get immediate consistency. But you need to police yourself to start asking this question. It's part of the user requirements. You also need to look at the data volume and velocity requirements. Yes, I'm talking about big data here. And because you want to figure out what these volume and variety requirements are, because you want to make an informed decision. These big data style requirements can force you to relax application data independence. And that's something that you should relax. I won't say unwillingly, or I won't say reluctantly, but it's something that you should be aware of when you're relaxing it, because application data independence is a very valuable thing. And application data independence, when we achieve it, it allows us to amortize the cost of collecting and cleansing and curating data across many different applications, and that's an economic win. There certainly are many situations in which in the big data world you need to relax that, but it shouldn't be your default. You should be relaxing it because the user requirements demand it. Okay. Keep some, discard some, stress some, change some. What you're changing here is especially high hurdle for you to clear. What you really change from when you become transform yourself from a relational data modeler to a conceptual data modeler is your whole attitude. You change what it is that you think is going to be engaging and satisfying about your job. Relational modeling has got this sort of mathy thing that is going to appear nerdy to users of this process of normalization, transforming your in-progress data models from first normal form to higher normal forms. I produce data models in greenfield situations. I produce data models in my technique for conceptual modeling that are in very high normal forms, but I haven't done normalization in the last 30 years, except when a professor in some academic environment has tested me on it and asked me to do it. There are other ways. The goal is not normalization. Normalization is a process. The goal is high normal forms, and there are lots of ways to get there. And one of them is a conversational technique that's described in this book I wrote with John Carless, a conversational technique that really forces you to kind of walk a tightrope, but it works for users. And the tightrope that you are walking is that you are trying to balance the needs of the users, and you're trying to have this conversation with users in which, because information is a cultural phenomenon, you're not a member of the culture, they are, the conversation has to transpire in their language, not yours. That's one of the reasons why you don't talk about foreign keys and all that stuff that's going to feel nerdy to them. But natural language is notoriously vague and problematic. There's vague category boundaries, there's categories that exist but don't have names, there's the homonym problem, there's the synonym problem. And so you want to allow this conversation to transpire in natural language, and at highly select moments, and you try to limit these moments, you want to tease out a little more rigor from the users than they would customarily employ. And the rigor that you want to tease out, this is where you have to police yourself, is you're accustomed to rigor meaning technological rigor. And this is sort of rhetorical rigor. It's rigor of categorization. So there's a very strange technique for how to do this. The technique is described in that book. The book is very technical, but it's not a technical book the way you might think. There's no powers of two in there. There's no Greek letters in there. It's technical in a linguistic and rhetorical sense. Also, for a little more, there's a lot more to be said about this than I could say in 30 minutes. You'll get a little more in a webinar that DataStax is hosting later on this month, that I will be talking a little bit more about these issues. So, you've transformed yourself from a relational data modeler to a conceptual data modeler. And there's sort of some new ways of doing work, and you've learned these new ways of doing work. The reason why you've done that is that you can help your organization make an informed decision about what the implementation meta model might be for a particular project. And that implementation meta model might be relational, it might be key value store, it might be array database, it may be something else altogether, object-oriented, XML, graph database. That is part of the reason, that is how you are making yourself useful in this new, not only SQL world, is you are understanding the data phenomena so that you can help your organization decide. When we start thinking about logical modeling and physical modeling in this NoSQL world, you will find that the state of the art is a little less mature than it has been for many years in the relational world. In particular, there's not actually that much difference that you can perceive between logical modeling and physical modeling for, say, a key value store. There's plenty of difference between logical modeling and physical modeling for relational DBMSs. That's the whole different. Those differences are what is connected by automatic forward and reverse engineering tools for ER Studio or from Computer Associates or Power Designer. But what you're going to find when you're thinking about logical and physical modeling for a key value store kind of environment is that the community needs to develop a new set of shapes, new set of patterns. In the relational world, people have got this roster of patterns in their heads, and maybe at the conceptual level, you see a many-to-many relationship, and okay, I recognize that shape, and I know a particular shape that I can use to render to render a solution to that particular user problem in the relational world, and it's 3 entities, 3 tables, with an intersection table between the 2 outer ones. That's how I do many-to-manys in the relational world. Or maybe at the conceptual level, still talking about the relational world, you see some sequence data. And you've got a couple of choices for how you might do that in the relational world. One is a table with a sequence attribute. One is a table with a one-to-one reflexive relationship for a predecessor-successor relationship. And you might make those choices in different scenarios accordingly. You need the same kind of roster of shapes in the key value store world. And that is really sort of a prerequisite for forward and reverse engineering tools. The way that forward and reverse engineering tools work is that they recognize shapes, and they recognize shapes on a model higher in that framework that I gave you, and translate it into a default shape at a lower level of that framework. Until we have those shapes, tool vendors are not going to be able to produce automatic forward and reverse engineering tools from a conceptual model to, say, a key value store model. You're also going to find minimal support for tools because just vendors have not caught up yet to NoSQL, and also because vendors really don't support conceptual modeling. Vendors of data modeling tools don't support conceptual modeling at all. And as I said before, the reason why they do that is because they don't support conceptual modeling, they dismiss it as something that's not terribly important. And that's wrong, and it's self-serving. Conceptual modeling is supremely important. Understanding the problem, of course, is important to trying to provide a solution. So let me just summarize, and then I'll open it up for questions. You want to recommit to conceptual modeling for requirements analysis. If you've got a lot of experience in relational modeling, some of that commitment, recommitting will involve transforming your skills that you've developed as a relational model into skills that are similar but are not identical. And most noteworthy about that is you are going to become a person who concentrates very hard on rhetoric and language for talking to users about their needs. You also want to remember some of those fundamentals that I put on the slide about information hiding and application data independence, because in the environment that you're working in now, you are going to be making some sacrifices about application data independence. And you want to make those sacrifices, you want to make those decisions in an informed way. You don't want to make the same kinds of decisions, same kinds of mistakes that the relational folks made. The mistakes that relational folks made was to just assume, well, we're in a relational environment now, so that's what I'm going to do. You don't want to be saying, well, we're in a NoSQL environment now, so that's what I'm going to do. You want to be figuring out what the user phenomenon is, what the problem is like, and then making a wise, judicious decision about what the meta model is, what the implementation strategy is that you want to employ. The other thing to be said here is that even in a purely relational environment, resuscitating conceptual modeling is going to make you better at your job and is going to make your clients like you better. First of all, users are going to like you better because you're going to be operating much more lean, and your conversations with users are going to be shorter. And your colleagues in the agile development world are going to like you better as well because you're operating much more lean and because your models are going to articulate much less and are going to be less subject to premature obsolescence because you don't have all of these constraints on it. You're just limited to entities, attributes, relationships, identifiers, and maximum cardinality. And now, I think it's time for some questions. Queries, as we database pros like to say. Yes?
Where do you situate object modeling in your consulting?
The question is, where do I situate object modeling in my cosmology of modeling techniques? I don't know if you said the word cosmology, but I'll use that. Object modeling is an interesting case because users do recognize different kinds of meta models. Users recognize structured data, they recognize unstructured data, they recognize geospatial data, they recognize image data. You can see all four of those kinds of data on a diner in some small town, on a menu in a small town diner. So it's not the case that users are unaccustomed to particular different meta models. Different meta models have arisen organically in the history of information. The object-oriented model did not arise organically in the history of information. The object-oriented model is a response to, is a concoction of software people to promote certain characteristics of software that users are not so interested in, like reusable software artifacts. And so I am not a fan of using UML class diagrams, for example, to do conceptual requirements analysis with users. In particular, UML class diagrams are about the runtime object model, and users don't care about the runtime object model. That's technology. Other questions? Yes, Camille.
Thank you, Joe. So I was in a session earlier where they were talking a lot about the miscommunication between the people putting their requirements for technology in, and then the technology that would come back would be almost a complete mismatch because of standards and budgetary constraints and whatnot. And I was wondering if a more thorough conceptual model might have helped the two teams, say line of business and IT teams, avoid these problems, or is that
The question, yes, that's terribly naive. The question is, what happens when, after a project is delivered and deployed, the users say, this isn't what I asked for at all? Would perhaps a more thorough form of requirements analysis or conceptual modeling help to remedy that problem? My answer is, you have to be very careful about the word thorough. Be very careful of rich notations. A better conceptual modeling technique will help to mitigate those problems. Better does not, in my mind, mean more thorough. In fact, in my mind, better means a couple of things. One of them is more spare. Make sure that you limit your conversations with users to those things that will help articulate the problem space and keep the solution space stuff at arm's length. The other stuff that you want to keep at arm's length when you're doing a data model is process requirements. At the conceptual level, you really do want to distinguish data requirements from process requirements because process requirements have data requirements have a much longer shelf life than process requirements have. Just think of any Dilbert cartoon that makes fun of a manager that's changing his mind all the time. That manager is constantly trying to streamline our activities. It's very hard in the absence of maybe a company acquisition to produce a model that actually changes the fundamental definition of categories. I think I have time for maybe one. I'm really sort of over. I'll entertain any question after this session. I'm kind of 1 minute over, and my sense of responsibility means I should shut up. Thank you.